Okay.
Her mom has coffee syndrome. So she's stuck in the hotel room by herself.
Okay, all your giggles are being recorded for posterity, so giggle politely, please.
What? Her brother's here. Her brother's here. She went to Tampa.
Right. Now then, we started yesterday in reminding ourselves a fair bit about linear equations. And I believe we just got into looking at the different slope types. Yes, indeed. Okay. We remind ourselves about calculating slope. Well, let's remind ourselves a little bit about slope. Basically, we got four possibilities for slope. Now we want to describe what these graphs might look like. One linear equation might have a graph that does that. The slope of this graph, what sign would it have? Positive or negative? Positive, and how do we know it's positive? It's going up, all right? We're going to say that phrase of going up a little more mathematically succinct, but basically slope is positive. All right, m is greater than 0. That says the same darn thing, right? Slope is positive. And we can also say the function is increasing. I definitely get that type of description in your vocabulary. Because next year when we start doing stuff with calculus, and we're talking about curves, the slope of curves. Where is the curve increasing versus decreasing versus changing and increasing? We're going to be talking about that a lot. Well, in fact, we'll talk about some this year as well, but more so next. All right, that type picture has a positive slope. Function is increasing. Well, how about it looks like this? What can we say about the slope here?
Negative.
Slope is negative. Okay, good. M is less than 0. And here, the function is, what do you think we'll say there? Decreasing. All right. Now, sometimes I don't think students have made all the connections we hope for them to. When we're talking about a function increasing, we're talking about the values of the function. Now, are the values of the function the x coordinates that go in or the y coordinates that come out? I'm calculating points. Let me ask you this. This would be one format of it. You don't have to write this down just yet. That is a linear equation. Could I not also write this in this form? Either y equals 2x plus 3 or f of x equals 2x plus 3. Now this says the function is 2x plus 3, right? So as I substitute values for x in there, I'm going to calculate out the value of the function. Like when I substitute, say, 4 in, the value of f at 4 is 11. That's the function's value. So again, I'm asking you, is the value of the function the x coordinate or the y coordinate? Well, I just put an x in and calculated a y out, isn't it? The function's value is the y coordinate. Every time. And see, I think that's something we overlook. It's a very, very basic concept that we need to make sure and connect. It is the y coordinate. So watch. When we talk about a function increasing, it's not that it's going uphill. Yeah, that's a nice convenient way to say it. But it's that the values of the function, the y coordinates, are getting bigger, 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 bigger. You always read the graph from left to right. And in this case, yeah, the values are increasing, they're getting bigger. Here, the values of the function going from left to right. As x is increasing, the function values are decreasing. They're getting smaller and smaller and smaller and smaller. So the function is decreasing. That's what we're talking about. What are the y values doing? What are the function values doing? Okay. Let's see. Let me demonstrate something here. This is going to be my demonstrator for linear equations. Nice and straight line, right? Not the curve we were talking about yesterday. All right? Positive or negative? Slope.
Positive.
Positive. Here?
Negative.
Here?
Negative.
There?
Positive.
Okay, which is bigger? This positive slope or that positive slope? First one is steeper. The values are increasing at a faster rate. All right? Tricky question. Which is bigger? This negative slope, A, or this negative slope, B? A is actually bigger. This would be like a slope of -1/4 maybe. Whereas that might be a slope of -4. Think about your number line. -4 is way out here, -1/4 is here. Bigger numbers are further right on the number line. That's a little tricky one sometimes. Okay, well, here we go. Positive slope, negative slope, right? Positive slope, negative slope. Think number line. Over here's all the negative numbers, right? Here's all the positive numbers. What's the one number right in between all the positives and all the negatives? 0. Now watch. Positive slope, negative slope, positive slope, negative slope, positive slope, negative slope. What's right in between positive slopes and negative slopes? What kind of line? They're all straight. Not vertical. Horizontal. Yeah. It's not a positive slope. It's not a negative slope, but it's right smack in between them, isn't it? That's horizontal. We all know it's horizontal. And the slope of a horizontal is always 0. That's going to prove to be a very important concept we got to know for calculus. Then we should know it for algebra 1. Alright? So if you have a horizontal line, alright, slope is 0. And that little visual is the way to kind of remember, because there's going to be a fourth one. And sometimes we get the third and the fourth one mixed up. So slope is 0, m equals 0, and here, what will we say about the function? It's clearly not increasing. It's not, the y values aren't getting bigger. In fact, the y values aren't getting smaller either. What are the y values doing? They're staying the same. I thought I heard somebody say the word I wanted to hear. Constant. The function is constant. It's always the same. It never varies. Right? The equation of a horizontal line is always going to be y equals some number. It says the equation is y equals some number. Like this guy right here, here might be y equals 3. Y is always 3. It never changes. There's not even an x to substitute in there, is there? Y is just always 3. It's always the same thing. Now, we make a big deal out of showing that because the next one is the one that people get it confused with. If it's not increasing and not decreasing and not horizontal, it's got to be what? Vertical. All right. And here, do you recall what the slope of this kind of line is? Good. Undefined. All right. And we say m is undefined. All right. And this one, we won't say the function is increasing, we won't say the function is decreasing, we won't say the function is constant because it's not even a function. Not a function. This guy fails the vertical line test all day long, right? So that was our visual test to see if an equation even was a function. So it's not a function. Right. This guy is going to have an equation is always going to be x equals some number. Every vertical line is x equals some number, whatever it might be that the x is passing through. So in this case, it might be x equals 2. X is always 2. It doesn't change. For some reason, students mix up these two all the time. They want to put x equals for the horizontals and y equals for the verticals. If you really stop and think about it, you know, here, y is always the same coordinate. It's always y equals whatever that number is. Here, x is always the same coordinate. X equals whatever that number is. Now, let's recall, and to kind of reinforce our idea of slope. Why is the slope undefined here? And why is it 0 there? How did we calculate slope yesterday? So I say it, you started. Yeah. We can calculate slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In this case, oh heck, I could pick out the point 2 comma 1, and how about 2 comma negative 3? Those are 2 points in the graph, right? Well, again, if I'm going to calculate slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what was negative 4 divided by 0? Undefined. You can't never divide by 0, can we? There's why it's undefined. Because the x coordinates will always be the same, and they'll always make you divide by 0 in a vertical line. Here, the y coordinates will always be the same. We'll have 0 in the numerator. And whenever the numerator is 0, as long as the denominator is not also, the fraction will be 0. Okay. So, we're remembering just the visuals. Positive slopes, increasing functions. Negative slopes, decreasing functions. 0 slope, constant function. Okay. Those are important concepts. We haven't talked about them so much since Algebra 1, but we've got to make sure we're going to have them down. Now, yesterday I think I had a phrase with a big star in it in your notes. What was that phrase, Austin?
To write the equation of any line, we need 2 things, a point and a slope.
To write the equation of any line, we need 2 things, a point and a slope. You got those 2 things, you can write the equation of any line you want to. But you've got to also remember there are different formats for the equation of a line. We've got 3 formats. 3 forms of linear equations. All right. First one, general form. Some textbooks will call it standard form. In this format, you've got a times x plus b times y plus c equals 0. When we're in this general form, the a, the b, and the c have to be integers. No fractions allowed. To remind ourselves about something here. When I say this is a linear equation, how do I know it's linear? By just looking at the equation. Well, how do we know a quadratic's a quadratic? By looking at it.
The degree.
The degree. The degree of both x and y must be 1. That tells you it's linear. X to the first power, y to the first power. This says linear. And thus, we're going to graph a straight line. The degree is 1. A nice straight 1 is going to be a nice straight line. Okay. Now here we can calculate the slope. And the slope is going to be negative a divided by b. Alright, and you've probably seen that little formula before. The y-intercept, I'll say the y-coordinate of the y-intercept, well, let's do y-intercept. The y-intercept is along the y-axis, so the x-coordinate is what? What's the x-coordinate of a y-intercept? Here's the y-axis. Graph crosses the y-axis. What's the x-coordinate? Yeah, 0. If my graph crosses the y-axis, what's that x-coordinate right there? 0. The x-coordinate of the y-intercept is always going to be 0. That's how you're going to find the y-intercept. Let x be 0 and solve for y. Alright, the y-intercept, in fact, okay. If we let x be 0 and solve for y, if I let x be 0, that term is essentially gone, isn't it? Solve for y. Negative c over b. X-intercept, if my graph is crossing the x-axis, what's the y-coordinate? 0. Always, right?
We need Nicholas Roney to report to Ms. Gibson's room, please. Nicholas Roney.
For the x-intercept, the y-coordinate is always 0. Well, to find it, if the y-coordinate was 0, then that term would go to 0, and we solve for x. Aaron, what's x going to be if I solve for x? X equals what?
80 times negative 2.
Not quite, not quite. If you had this, solve for x. You subtract the 8 and divide by 2, right?
Yeah,
Okay, so solve for x.
negative c over 8.
There you go. Good. Now, that's all the mathematical formulas right there. I've honestly never, ever memorized those. I can figure them out every time. It's easy enough to just do the little division and stuff that Aaron just did to figure it out, right? But if you want to memorize, if you're a person that likes to memorize and know it, there you go. All right, that is general form. An example of general form could be 2x plus 3y minus 8 equals 0. That's an example. If that's the case, what's my slope? Negative. Negative 2 over 3. Getting there. Yep. Y-intercept, yeah, we could go through this, figure it out. 0, well, negative c over b, 8 over 3. Yeah, we can do it like that. It sure seems like to me, though, it's a lot easier to just say, oh, the y-intercept is when x is 0. Solving for y, I'd add the 8, divide by 3. I get it. To me, that's easier, honestly. But you do it how you like. Okay, that's general form. But you're taking the ACT and you found the equation of the line and you got general form, but that's not choice A, B, C, or D. Because maybe they have it in a different form. So, what's another form of linear equations? One you guys probably used a whole lot. No, I don't know what that's referring to.
The point slope,
Pardon me?
like the point slope.
There's that one. That's my favorite. I'll do that last. How about this? Slope intercept. That's what you're thinking about, Abigail?
Yeah.
Okay.
Michael.
Yeah, that's what most people jump to right off the bat. It seems like most Algebra 1 teachers focus on this one 98% of the time. Uh-oh, we're out of time, aren't we? Okay, here, m is the slope, and the y-intercept is the point 0, comma, b. Thus, they call it the slope-intercept form, right? We can just pick out the slope and pick out the y-intercept by just look at the numbers. If you're given, y equals 3/2 x minus 4, well, this isn't rocket science here. What's the slope? All right, 3/2. And the y-intercept is 0, -4. Thank you for expressing that as a point and not just saying -4. The y-intercept is not -4. The y-coordinate of the y-intercept is -4. Bell's going to ring in. I'll see you in just a second. So you got it. Yep. Okay. Haley in the front office for something. And I believe the bell is going to ring in just about 10 seconds. 40 seconds. Well, we didn't get to go quite as far as I wanted to. Not sure what we can do here. Ooh, different book, that's for sure. Let's go with page 181.
Need Danielle Mason to the guidance office,
Page
please.
181, let's
Also,
get
any student who just received a National Honor
1
Society
through
card,
12.
please report to Ms. Gibson room
And-
during the afternoon break. Does any student receive the National Honor
21
Society
to
card?
23.
Please report to Ms. Gibson room at this time.
1 through 12.
Sorry, Sona.
All right, so for Bailey, again, we're page 181, 1 through 12, and 21 through 23.